Hello viewers, welcome back to my channel. In this video, we'll be talking about some properties of Laplace transformation. The first one, we call it linearity of Laplace transformation. Can I spell it? Linearity of Laplace transformation. Okay. Now, this one simply says that the Laplace transformation of a f of x plus b g of x, that you can share it for them, that this is equal to, I can't write here because it will not contain, that this is equal to a, the Laplace transformation of f of x, okay, f of x. We can use t, let's use t, because we are not, I don't know why I am used to x, but let's use t, okay, it's the same thing anyways. Then plus b, the Laplace transformation of g of t. All right. Now this is the first one. Now the second one, and very important one you need to know, is that I hope you know that the Laplace transformation of f of t, okay, is equal to the integral from 0 to infinity of e raised to power minus st, then f of t dt, which we call capital letter F of s, okay? We call it capital letter F of s. It's always a function of s. The Laplace transformation is always a function of s. Now, this one, from here, we know we should have that whenever you are given the Laplace transformation of e raised to power at, then f of t, okay? When you combine e raised to power at by f of t, that is equal to the integration from 0 to infinity of, first of all, the normal person, that is minus st, then put everybody here, multiply by e raised to power at, then f of t dt, okay? So now, this is equal to the integral from 0 to infinity of e raised to power. According to indices, we are going to add this, so I'm going to have minus st plus at, right? Then my f of t dt, okay? So this is giving me finally the integral from 0 to infinity of e raised to power. Arrange it very well. This is something I'm saying at minus st, okay? Then f of t dt, okay? So this is the same thing as saying the integral from 0 to infinity. Now they have t in common, so I can write it as e raised to power a minus s, right? The s minus a. Okay, according to Laplace, minus is always coming out, so let us arrange this very well instead of putting it this way. So what we do is to bring out the minus, okay? So this is going to be the integral from 0 to infinity of e raised to power. If I bring out minus, I'm going to have that here is st, then minus at, okay? Then f of t dt. This is better. So now I'm going to have that this is now the integral of minus, if I bring out t that is common, minus s minus a, then t, then f of t, okay, dt. So you see that this will now give us a function of that s minus a. Is a function of this s minus a, okay? Now these two important concepts are very, very important. They are very, very important concepts. Now this will now give us, from this second one, it will let us to know that the first one, that the Laplace transformation of e raised to power at, then with t raised to power n, okay, should give us what? Normally, you should know that the Laplace transformation of t raised to power n is equal to what? N factorial, then I have s raised to power n plus 1, okay? Now, since you have this, use this now and compare this. The way we use this to compare this, you will now see that this one should now be equal to what? N factorial. We don't have any business with n. It's always a function of s. So all over, instead of putting s here, I will now put s minus a. So this will now be s minus a, then raised to power n plus 1. Okay? That's the first concept from here. Taking note of this. Then number two we should take note of is that the Laplace transformation of e raised to power at with sine at. So what do we have? Now this is going to be, normally we know the Laplace transformation of sine AT, okay? The Laplace transformation of sine AT is equal to, I thought that if it is sine, that A will start it, so it's going to be A over S squared plus A squared, okay? We know this. So from here, we can now have that this one will now be, what? A over S minus A all squared plus A squared, okay? So that is that for that. Now let's go to the next one. Number 3. Can you permit me to clean here? So cleaning here, we'll be having okay. Number 3, if we now have the Laplace transformation of e raised to power at by only e raised to power at. You know that it's saying the Laplace transformation of e raised to power at should give us what? Now let's see what it's going to give us. We know normally that the Laplace transformation of 1 is written as what? 1 over s. We know this one, right? So now this thing is written as saying this times 1 here. So, and don't forget that whenever you have e raised to power at, that is going to be a function of s and a. So this is now what? 1 over s minus a. So that is what it is. Don't forget. Then number 4, if we now have the Laplace transformation of e raised to power at multiplied by t. So what do you think it will be? Normally, the Laplace transformation of t should give us what? 1 over s squared, right? Yeah, 1 over x squared. That is. So this one will now give us 1 over s minus a all squared. Then it's from this concept that we got. It's from this concept that we got this number 1 I wrote here. Okay. So number 5. Let's go to cos. The Laplace transformation of e raised to power at. Then cos at. What do you think it should be? Normally, we should know that the Laplace transformation of cos at gave us, I told you if it is cos, it will start from s. So s over s squared plus a squared. So because this one has a, it will now be s over, here will now be s minus a all squared, then plus your a squared. You should know that here should be s minus a as well. Okay, anywhere you see s, just put s minus a. So we go to the next one. Number 6. Permit me to clean here. I hope I'm not fast. If I'm fast, please rewind it and watch it 3 times. You will understand. Number 6. Number 6 said, what is now the Laplace transformation of e raised to power at, okay, then sine at, okay. Now we know normally the Laplace transformation of sine at is the same thing as saying what? Let's go. Is the same thing as saying, I told you that the difference is that here is always minus a sine. So I told that sine will start from a. So this is a over sine, a over s squared minus a squared because of this sine. Okay, so this one should be what? This one should now be what? A over s minus a all squared, then minus a squared. So that is that. Then number 7 said the Laplace transformation of e raised to power at cos at. Okay, you should know again that the Laplace transformation of cos at, okay, is equal to, you start with s over s squared minus a squared, right? So what do we do? So this one should now be what? S minus a all over s minus a all squared minus a squared. So that is the Laplace transformation of that. So you see what that concept gave us. This thing will help us in solving so many calculations. Okay, it will help us in solving so many calculations. So let us move. All right, so that is that for this video for the properties of Laplace transformation. So in the next video we'll be giving examples of solving more examples on Laplace transformation before we now enter inverse of Laplace transformation. Thank you very much for watching this video. Please encourage us by subscribing. If you are new to this channel, then you can like this video and comment so that YouTube can recommend it to other viewers. May the peace of the Lord be with you for our returning subscribers. Bye bye.